So hello guys, this is another question from IIT JEE PYQ. This question is an important question on the point of view this JEE Mains and JEE Advanced. So here is the question. An ideal spring with spring constant K is hung from the ceiling and a block of mass M is attached to its lower end. The mass is released with the spring initially unstretched. Okay, the maximum in this extension in the spring we have to tell. So here is the situation. This is our ceiling here. Initially, let us suppose this is our spring and we have connected a mass M here. So here the spring constant is K and let me call extension in the spring is 0. So it is unstretched. Then after releasing this mass M, what will be happening? There will be an extension in the spring. Let me draw here like this. This is the extension in the spring and here is the mass M. Okay. Let me call it, this is the extension in the spring is X. Right. So here I can clearly see that one situation. Initially, before releasing this mass M, the initial velocity of the particle, this block of mass M was 0. And let me call this is the situation when maximum extension in the spring. Then at this point also velocity of the particle will be 0. Okay, because after this instant particle will not be moving, it will be moving in backward direction only due to the restoring force of this spring. Okay, so here I want to apply, since acceleration due to gravity is also acting in downward direction, so there will be role of potential energy here. So let me call it, this is the level 1 here and this is the level 2 where maximum extension in the spring is given. You have to calculate, right? Now I want to apply the conservation of energy at level 1 and 2. Okay, so here at level 1, what is the total energy in the system is, if I take this level 2 is the reference point. Oh wait, let me take the level 1 as the reference point only. So this is what I am taking reference point for the potential energy, reference point. Okay, it is the reference level. So total energy at level 1 will be what? Kinetic energy, that is kinetic energy plus potential energy at 1, that will be equal to what? Kinetic energy plus potential energy plus kinetic energy plus potential energy at level 2. Okay, so now I will be substituting all the values here. So at level 1, what is the value of kinetic energy? Since velocity of the body is 0, so kinetic energy will also be equal to 0 plus since I am taking this as the reference level, so here potential energy of the body will also be equal to 0. And since there is not any extension in this spring, so here spring potential energy will also be equal to 0. Okay, so this will be equal to what? What is the kinetic energy of body at the level 2? That is that final velocity is also 0. So this kinetic energy will also be equal to 0. Now plus what is the gravitational potential energy at this level 2? That means we are going in downward direction. So this is the level, this is the reference level, and let us suppose we are going x distance in the downward direction. So there will be a negative mg into x. This will be a potential energy due to gravitational potential. Okay. Now there is extension in the spring that is equal to x. Okay. So due to this extension in the spring, there is a spring potential energy stored in this spring that will be equal to half of kx square. Half of kx square. So if I take this term in this side, then half of kx square will be equal to mgx. Okay, so here x will be cancelled out, and if I want to find out the value of x, that will be equal to 2mg divided by k, right? So this is the maximum value of extension, in the spring. Okay, So this is the method we have to use here, and the value of that 2 mg by k, that means option B is correct here. Okay.